What is up, you guys? It is Hamid Abdul, and I'm finally back with another Unity tutorial. Delicious. But anyway, so it has been rather a while since I released the last one of these. Probably more than a month and a half, just about. Basically, just to sum things up, ever since I got out of school, I haven't had the willpower or the strength. I've just been too distracted to focus. I'm sorry, I keep staring at the massive, there we go, massive pile of clothes that I need to fold up. I went on vacation, my birthday, bed bug infestation, graduation happened for various schools and people that I know, so yeah. Hanging out with friends before my internship started, a whopping 4 weeks ago, trying to pump out as many other videos and do other things other than focus on what's important, because I want to be able to prepare myself for different events that are coming up, take the Unity certification test, get more experience, have C++ in the fall, and game jams that I want to travel to, just all this good stuff. And long story short, I haven't been able to focus. This was supposed to be done in June. I haven't done it. It's not done. Just to give you a feel for what's up, I did make a project plan, or I wouldn't say plan, but outline of things I want to touch, because we want to recreate the very first world, not world, but stage. And yeah, that's pretty much everything I can think about it. And without further ado, let's get right on to the Unity. So today, what we're going to be focused on is getting our player to move. Not our player, sorry. Our enemy to move. Just where we left off, we had a couple problems also with the jumping mechanics, which I'll have to take a further look at and get back to you guys on, because I don't want to do anything. I guess you can say I don't want to freestyle in this video. I want to follow things as planned, because that's how I get off the stray, and it takes months for me to get back to you guys. So we're going to do as planned and focus on the enemy movement. And major shout out to Devin Curry, because he created a video on moving mechanics and layer masking, and just his whole entire script and tutorial really helped out. So mad shout out to him. Be sure to go check out his channel and his page, which has all this information tutorial. You can also become a patron and donate. He's a great guy. Well, I don't know him personally, but anyway, without further ado, yeah, I just wanted to give him props. So if we press play, here's what we're looking at now, because it's been a month. So yeah, player can move. There's still no physics on our prefabs. What the crap? Oh, that's a coin block. Sorry, that's 10. So we run into the Goomba, die. Koopa Troopa doesn't turn into shell. Jumping seems okay for now. But okay, what we want to be able to do is get these little suckers. We want the Goomba Troopa. We want the Goomba and the Koopa Troopa to be able to move left and have the ability to turn around if there's an obstruction, such as a blocked pipe or anything that it's in the same, I guess you can say, a predefined. It makes sense in the Mario universe. Obviously, green Koopa Troopas and Goombas cannot turn around on cliffs. That's only red Koopa Troopas and various other enemies. That's not what we're dealing with. We won't be dealing with that on World 1. So yeah, there's no need for them to turn around that way, but if you want to know how to do that, Devin Curry does a good job doing that in his video, and that's pretty much what this is, me pretty much rebranding his script and tailoring it towards being able to turn around. Other than, I don't even think I rebranded it, because I think he went over this. So yeah, I just stole the thing. Great art, good artist copy, great artist still. So yeah, anyway, let's go straight. Well, we can't go straight in Visual Studios, but we're gonna go to our good old Goomba Troopa, and let's make a new script, and let's call this the enemy movement script. I'm just leaving it enemy movement. Totally up to you on what you want to name it. Name it Batman for all I care. Let's open this bad boy up. Reload all. Where you at, fam? Where are you? Oh, there we go. Okay. So with the script in mind, we wanted to find out a few things, and before you get all feisty and want just code, we're going to be doing some major commenting. So let's get rid of all this in between of curly braces. Oh, sorry, I have to move my mic out of the way. And yeah, let's put this here. I'm making sure that I stay on task because I have bullet points and notes and everything, and it's gonna be beautiful. And you guys are gonna love it. And if you don't love it, then you can suck it. So yeah, what we're gonna focus on is being able to turn around. So with that in mind, we want to predefine a couple things like our player's speed, our player's transform and position, depending on what we're going to do, and also boundaries that we're going to cast lines from. Devin Curry does a way better job of doing this than me. So if you want like an in-depth description of everything, go to him. Because me, I suck. But yeah, I want to suck less. So this is why I'm doing this. But so pretty much the purpose of the script is to be able to define a script. We're gonna want to define a script that allows us to move our player in the opposite direction of move our enemy in the opposite direction of our player, and be able to turn around if one of the obstructions that we allow it to turn around on. And to do that, we're going to need not only things such as speed and a float variable defined. We're going to need boundaries, which are going to be float variables as well. You're going to need your rigid body stored in a so you can shorthand it. You don't have to store it, but it just saves so much time. You're also going to need a way to turn vector 2s into 3s because of the way that line casting works and what we're trying to do and accomplish with the script. So it will be able to, the line will be able to, I'm trying to make this looks so sexual, be able to originate from the player, from the enemies, at a defined point that we define with one of the float variables, and on our bounds and extents, and then in the X and Y axis, so it'll be able to go from the player and the way that it's facing, and from that it will turn around and do all types of cool things. So yeah, that's pretty much what let's just get to coding. So we're gonna want a public float variable for our speed, and right off the bat I'm gonna give it something like 2.7. I don't know. 2.7. Then we're going to want a public layer mass, because all this is going to happen, what the enemy will be able to interact with and move through, or what its movement will be bounded to when it turns around, is all based on the layer mass collision that we do from this point. And it only gets thus more complicated as we start doing Koopa shells and object. It's just annoying because ray casting is you don't even know. I've been even though I've taken a month off, I've been playing around, and it's a headache. So layer mass, let's call this enemy mass, and leave that there for now. And we're gonna want some private variables. So transform my trans. Then float is gonna be my width. So that's gonna be the width of our enemy object, and my height, which is going to be the height of my enemy object, which is not really, doesn't take a rocket science to figure that out, but it's going to be stored in, you'll see, it'll be stored in a float value. That way we'll be able to access it through certain means. So rigid body 2D, shorthanded to RB. Let's open up this void start. And let's get started with our shorthanded variables. That way we can save ourselves some time and headache. So what we're gonna do is my trans. Oh, first, no, we're gonna comment. Oh, comments do not start with periods. So shorthanded placeholder, shorthanded variables to save time. My trans equals this dot transform. So basically what we're doing is all these private variables that we established here and gave no value, we're doing that now. Shortened variables, assign to existing, or should existing or preset? Previously set values. To save time. Okay. You don't have to get that deep, but that's just you. Commenting is sexy. Just so you know, commenting is really sexy. RB equals damn, this dot game object dot get component. So we are forced to use get component because the nature of the beast. Sorry, the parentheses go on this side. It's been a while. I'm kind of rusty. That's why I have the notes, just to help me get started. It's not that I'm a total noob, because yeah, it's just. So we're going to want a sprite renderer. Sprite renderable, type name my sprite, and we're going to assign this game object dot get component sprite renderer so this, the reason why this wasn't defined elsewhere, you could, but I don't think this can be defined without assigning it to a value, or if so, you're just going to confuse the players. I don't know. You could. You probably could. Matter of fact, hey. Shoot. Copy. Hey, you could. You definitely could. But, yeah, just keep things formatted, because that's going to drive me insane. Yeah, let's do that. You could do that. I don't know why I haven't done it that way in the past. See, that's the beauty of doing things over so many times, because it instills with you. It helps you. And, yeah, that's what I plan on doing with Unity. Doing it so many times that it just collects extents. So my sprite.bounds.extent.x. So your width is going to be the horizontal plane, because think that the width of you, how, you know, horizontally challenged or horizontally obscured a person is. Not trying to call someone a person like overweight or bulimic, but just to give you some relative analogies. And then we're going to do the same, or likewise with my height, which will just be vertically. So if you're like me, and all your friends tower over you, because you're only like 5 foot, I think 7, 8, 9, I don't know how big I am. And then all your friends are 6'4", then, you know, yeah. So same thing relative to your vertical. And this is just going to help us when we start to cast our line and do our line casting, which is about to happen. So avoid fixed update, because we will be doing some physics C stuff, I think. Yeah. Okay, flip the page. Let me know, turn this side. Okay, so what we want to do is we want a way to be able to ignore collision between two different layers. So what we're going to have to go back and do is establish set layers that the player is on, and set layers that everything that it's going to interact, or how it's going to interact with layers that have already been established, or layers that will be established in the future. So right now we know right off the bat that we want it not to be able to collide with the level boundaries. Think about it. Whenever you're playing the opening sequence of Mario and you jump and you miss the Goomba, it keeps going. It doesn't stop at the end of screen. It's like, oh no, let me turn around. No, it just keeps going. So we want to find out, be able to know what layer these are on. And I've probably already made these because I've done this tutorial like 7 different times, because OBS, yeah, just making sure OBS is working. OBS and my computer hardware, I'm just an it takes me a while to optimize things to my situation. So yeah, I've done this tutorial like 7 times trying to record it, and it is flunked every single time. But hopefully not this time. Better not be this time. Okay, so what you want to do is go click your layers. No, that's not what we want. Edit layers, sorry. This radio little drop down menu, edit layers, and you can see all your layers, default, water. So user layer 8 is where I have mine in. So enemy is user level 8, user layer 8, and level boundaries is user level 9. And you want to set these accordingly. So your Goomba and Koopa Troopa prefabs need to all be on the enemy layer. And likewise with your level start and end, they need to be on your level boundaries layer. Sorry, I was looking at the tags for some reason. They need to be on the level boundaries layer. So let's make sure that these are, see, these right now are on the default layer. I totally missed that. Good thing about going back. So yes, change. They are on, no, not layer boundaries. Okay, I think I saw it. All right, they are on this. So let's go here, apply, here, apply. So every prefab will be like this, the step. Instantiated or brought into the scene having this setting, this predisposed default of being on the enemy layer. So yeah, and with that established, we want to be able to ignore collision between those two layers. So anything that is an enemy and has this script, the enemy and the level boundaries. Okay, and that's going to be done with physics 2D dot ignore layer collision. And what you want to do is the number that the layers are on, the number of the first layer and the number of the second. It doesn't matter which order, just make sure that it's the right layer, it's the right number corresponding with the layers that you want not to interact with. So we're just going to keep things simple and do 8, 9 and a semicolon, and that should wrap that up. And now, here, it might help if I zoom in a bit. Let's get that. Yeah. And all this will be, I'll make this all available via project files and assets that you can import, export, and do whatever. So yeah, don't worry. And yeah, you can always pause the video and see all this. So yeah, don't worry. This may be a little too much. Maybe a little. I don't know your needs. So let me know. Feedback's good. So yeah, now that our layer is established, we want to go on casting a constant horizontal. Oh, that's not what I don't like the way casting a horizontal line. Let's leave it like that. That moves with the enemy object. So that's going to be physics.2d.linecast and excuse me, sip on some tea. Tastes like leprechaun piss. Ugh. Anyway, this is going to be done via using our transform. So transform is going to be shorthanded with our mytrans. So it's going to be mytrans dot position dot 2 vector 2. So another thing, with this said, you're converting this. So my transform dot position is a vector 3, and we're going to want to change this to a vector 2. That way it will work with our line casting, which is being called with the physics.2d or physics 2d, and wouldn't have to do this if things were 3D, but they're not. So we're gonna have to make another script. Just work with me. Oh no, that's Pokemon. Sorry about that. Okay, gonna make another script, and this doesn't have to be. Here it is right here. The extensions method. I made this already because, like I said, it's second time third time, fourth time doing this because I've done this over and over and over. Create new C# script. We're gonna name this extension method. Reload. Yeah. Okay. Get rid of these things inside the curly braces. Let's make this. So this is going to be right off the back. Where you see public class dot extension method or whatever you name this, before class, put in the keyword static. This is going to be of the static type, so that way all across the board, anything trying to access this will be able to access not only the script, but also it will be the same. Me just defining static, the static type is just, it's weird. Go to Devin's Curry page if you really want to get in depth on how this goes about, because he made the script. Well, he's claimed to make it. You got me, fam. So inside public static vector 2 vector 2, and that's going to be inside parameters. You're gonna, this vector 3 vector 3 vec 3. So inside of that, and then we're gonna have so inside of that, you're gonna have return new vector 2 vec 3.x, vec 3.y. So what this does is that this script basically, it converts the first two axes of the vector 3, which are your x and your y, and changes them into a vector 2, because vector 2 can only have two coordinate axes, planes of axes, and it can't have three, which is the z axis. So you're just gonna basically take the x and y axis from the vector 3 and convert it to vector 2. Plain and simple. I don't know why this didn't click to me to explain it that way, but you know, hey, and we're good. Static class extension method cannot derive from static, must derive from object. Did I tell you wrong? Public static class. Okay, so public static class is correct. You're gonna have to remove the mono behavior, assigning it to this. So just remove that and you'll be fine. Like I said, technically I cannot, I'm so ignorant and I don't want to tell you the wrong thing. So better yet, you might know more than me. So be sure to put that in the comment section and let me know. So yeah. Enemy movement, reload. So basically, yeah. My trans dot position dot 2 vector 2, and that's going to be minus my form my trans dot position dot physics dot 2d dot line cast, ignore collision casting line. Oh, okay, minus my trans dot right. Okay, right dot 2 vector 2 times my width minus, no, plus vector 2 dot up times my height. Let me, forgot the parentheses. Line cast pots. Okay. Oh, this has to be a vector 2. Sorry, it's not physics.2D just yet. Vector 2 physics. Sorry, I just said that. Line cast posh equals. You could say equal. Yeah, you should say equal. Okay. And that is not it, because, okay, what we have here, this is our current position, of our enemy minus the position, the distance between its position from the right. So imagine, how do I explain this? Imagine that it's using another vector to come inside from the edge of the position. I don't know how Unity goes about doing that. It's probably some super technical European magic that happens. But so a vector is, it's basically doing a vector from the right side. So it's minus that times its width. So yeah, it's just making sure that its width is aligned with the origin of position and its coordinates and everything, and then that's going to be plus up times, it's vector 2 plus vector, can't speak, plus vector 2 dot up times my height, which makes sure that that line that's being drawn is not down here on the ground near the base of its origin, or let's say the right-handed corner. If this was the center of it and the base was down here, that would be like what? Quadrant 4. We want to make sure that it's level with the base of origin. So it's evenly distributed between the height and width. That's the simplest way I could put it. And that did not deserve that long of an explanation, but it got one. So yeah, pretty much that's what it is. And also, we want to determine how long this line is going to be, which I also forgot. So that's going to be times 1.2 world units in a float value world units. So just to give it a little bit more oomph to make sure that it's extending past the player's collider, it's not getting in the way of any physics that are going to happen or that are going to be futurely or implemented in the future. So yeah, just to get that out of the way, let's make sure everything's good.